Dear students, welcome back. In the previous session, we have discussed about rectification of currents, isn't it? Now, in this session, before we are going to start about the direct current for the treatment of patient, first you should know the therapeutic currents. What are the types of currents or present which are used therapeutically? That thing you should know. So for that I am going to give what are therapeutic currents and their classification. Especially this classification is for low frequency currents. Okay, so before starting with the classification, just we will revise what is wavelength and the frequency. Then you will get a clear idea which is called as low frequency currents and high frequency currents. What do you mean by wavelength? Wavelength is the distance between a point on one electromagnetic wave, okay, and exactly the same point on the next wave. So that means again, so this is one wave which is starting here and here up to here, and again this is the another point of this wave. Okay, in this diagram you can see they have taken A is one point, so the wave which is started here and again the same point in the another wave is taken here. So the distance between a point on one electromagnetic wave and exactly the same point on the next wave is called as wavelength. Okay, so this is also another wavelength. So from here to here we can calculate here, or this one to this one. Okay, next. So this wavelength may be very long. Okay, this wavelength may be very long. So normally wireless waves being measured in hundreds of meters or very short, okay, this hundreds of meters or very long wireless waves which belongs to the radio waves. If you come to very short wavelengths, then we can move on to the ultraviolet waves and also X-rays, gamma rays and cosmic rays, which are all measured in nanometers. So if you see this electromagnetic waves, as we know that in the electromagnetic spectrum, so you can find at the middle, this is the visible light, isn't it? This after visible, if you move on to the right side, you'll get the infrared rays and then the radio waves. So here from the visible waves, so all these electromagnetic waves will have the same speed, but the wavelengths are different. Here. So here you can find infrared. So this wavelength is about from 750 nanometers to 4 into 10 power 5 nanometers for infrared, and the remaining one is 4 into 10 power 5 nanometer to kilometers, which comes the radio waves. So these radio waves will have longer wavelength. So here we'll have the visible. Visible is in between 400 to 750 nanometers. So, and left side of this visible light, so here the wavelengths are going to decreasing. So you'll find ultraviolet, these are very short. So, and next comes to the X-rays. These are still very short than ultraviolets, and then you can find gamma rays. Okay, these are still lesser than this one, and then next one is the cosmic waves. So this one is still less than that of gamma. waves. So that means if you see here, so beyond this visible range, so here the long wavelength, it can travel so much of distance. Here if you see this ultraviolet and X-rays gamma, they can't travel most of the distance, but it will go in depth to any heart tissues like this thing. So X-rays, so the X-rays are passing in depth, which are going to give the pictures of the bones, isn't it? So it can, the short waves will travel in depth. How much depth? They can travel in depth, whereas this long wavelengths will travel so much of distances. So that means it may travel to kilometers. So they are comes under this radio waves. Okay, that means if you see, these are longer wavelengths, but the speed is same for all the electromagnetic waves. All the electromagnetic waves will have the same speed, but different wavelengths and frequencies. So now what do you mean by frequency here? Frequency is the number of complete waves passing any fixed point. So here in this diagram you can see, so these are the two fixed points. So how many waves, that means complete waves, crest and troughs. Okay, how many complete waves are passing in any fixed point in 1 second, then we can call it as frequency. The long wavelengths will not have much frequency, because if you can see, this is a long wavelength which is having only one wave, complete one wave in this particular point. So that means in this wave B we can find 3 or 4 waves, isn't it? So that means if you see the wavelength of this wave A and wave B, so this wavelength of A is greater, so it is longer wavelength. The wavelength is short compared to this wave A, then it is shorter wavelength. If you see the frequency, the number of waves formed in a fixed point per second is also low, then it is called as low frequency. And the waves, so that means number of waves are formed, then it is called high frequency. Okay, normally the frequency is measured in hertz. That means, so in 1 per second, number of waves are formed, isn't it? So one formation of single wave, this one is called as hertz. Okay, so how many occurrences of these waves are formed within 1 second, then it is called as hertz. So that means for a low frequency, so the frequency of this currents, we can call it as, it varies from 10 to 1000 hertz. 10 to 1000 hertz are called as low frequency currents. If so, there is another waves are also present called as medium frequency. So it is not belonging to low frequency or high frequency, it falls in between them, that is called as medium frequency. Those frequency are in between 1000 to 10,000 hertz. So that means in a fixed point, how many waves are formed in low frequency? It may vary from 10 to 1000 hertz, then it is called as low frequency. So when you see if the waves, occurrence of this waves in a particular point occurs in between 1000 to 10,000, then it becomes medium frequency currents. And next one is the high frequency currents. That means the occurrence of this waves is above 10,000 hertz, then this is called as high frequency. As the frequency is increasing, what is happening? The wavelengths are decreasing. That means the frequency and wavelengths are inversely proportional. Okay, so if you see the low frequency, then it is having longer wavelengths. Okay, based upon frequency, the therapeutic currents are classified into three types. One is the low frequency currents, next one is the medium frequency currents, and then the high frequency currents. Okay, so normally the medium frequency currents having three types of currents. One is Russian current, Reebox current, and interferential currents. Okay, if you see the high frequency currents, it is having four types of therapeutic use. One is microwave diathermy, shortwave diathermy, and long wave diathermy, and ultrasound comes under high frequency. Okay, low frequency will have different types of currents. Okay, low frequency is having different types of currents. Okay, now we will see the classification of the low frequency currents based upon the directional and waveforms. Okay, now we will move on to the classification of low frequency currents. Yes, so this is based on the directional and waveforms. Okay, so what is the frequency of low frequency currents? It falls in between 10 to 1000 hertz, then it is called as low frequency currents. Okay, now this normally this current is divided into direct current and alternating currents. Okay, so this is the based upon the direction, it is divided into direct current and alternating current. So what is happening in the direct current? This is a continuous unidirectional flow of charged particles with duration of at least 1 second. Okay, and in the case of alternating current, this is uninterrupted. So this is uninterrupted bidirectional flow. This is uninterrupted bidirectional flow. Normally the current will flow like this in a straight, only one direction, whereas in the alternating current, so it can change the direction of the motion of the charged particles. Okay, this is called as bidirectional flow of charged particles, and changing direction at least once per second. And also another type of current is there, that is pulsed current. Okay, this can be unidirectional or bidirectional. So that means this pulsed may be assumed like a direct current as well as alternating current also. The flow of charged particles stops periodically for less than 1 second before starting of the next event. That means a burst of current we can see here. That means once a burst of current, that means a current starts and increases and falls. So this is called a pulse, and it waits for at least less than 1 second, and again next burst will come. So next burst of flow of electrons, then which is causes the increasing and falling, and again will get 1 second of time, then it is called as pulse type of currents. Okay, now so but we are in the classification we are taking this direct current and alternating current. So this direct current is also divided into two types based upon its flow of current. That means whether it may be uninterrupted, so you can find such kind of graph. If it is interrupted but it is moving in the same direction only, okay, so like this, okay, so here in the same direction only it is formed, it is not reversing, so like in alternating waves. So but there is an interruption appeared here, such kind of interrupted direct current comes under this direct current. Okay, so the direct current is divided into uninterrupted and interrupted. In the uninterrupted we can see plain direct current, which is called as galvanism. Plain direct current, which is called galvanism. And if you see the interrupted type, based upon its duration, how much time it is going to interrupt in between the waves, then it is called as short duration and long duration. If it is having very shorter time, then it is called as shorter duration. If it is having a long time of interruption, then it is called as long duration. Under short duration we can get the Faradic type of current. Under long duration we can get galvanic type of currents. Okay, that means Faradic interrupted direct current we can have, galvanic interrupted direct current is there. So what is the difference between Faradic and galvanic? Means the Faradic current or short duration interrupted direct currents, whereas the galvanic type we can see here are these are long duration interrupted direct current. This is the galvanic. If you see the other type of low frequency current is the alternating current, and this alternating current is going to be modified. This alternating current which is going to modified into two types, one is sinusoidal and diadynamic. So these are the types of alternating currents which comes under low frequency currents. Now in the next session we are going to discuss about in detail about this direct currents as well as the alternating currents. Thank you.